Welcome to the examples video for working with trig graphs. In this video we'll go over some core examples as well as to walk through some past paper questions. In the first concept video for working with trig graphs, we looked at where the graphs come from, the two types of vertical transformations that we can perform on the graphs, the amplitude of graphs, and also why we care about these things. And in the second part, we looked at the horizontal transformations, the period of the graphs, and again why we care about it. And then we'll go on to do a walkthrough of some key examples. We'll start off with examples from the concept videos. So this first question is asking us to sketch the graph given us the equation. And we'll make a few notes in regards to the equation first of all. So this guy in front here corresponds to change in amplitude, which is, since it's less than 1, it's a compression. So it'll be shrunk vertically compared to the regular cos graph. And this guy in the end here is a vertical shift, and it's a shift downwards because it's negative. Okay, cool. Let's draw our axes and get started. Make it nice and big so we can see what we're doing. And we're plotting, put that on the other side, we're plotting y against x. So on these sketching questions, I also always like to start by just writing down the regular cos curve, or in this case cos curve, sometimes it's sine curve. And then doing the transformations afterwards. So we'll start here at 1, and it'll be down to minimum at -1, which should be here. I'm just in pencil just to show you that it's not the actual final answer, but it's good to show steps. Okay, let's get started. Hopefully this isn't too bad. I'm not great at drawing, but it goes up like something like that. I'll redraw that, but you probably get away with that in your exam. That was a little bit better. We'll stick with that one. As long as you've got the general features, you won't get marked down. I will mark at the end here. That's 360 degrees. I don't need degree sign because we're a degree sign on the axis. Okay, cool. Right, let's deal with the first transformation. We've got a compression, so let's deal with that first. I'll swap colour. And compression just means the graph's going to shrink to half its size, so it'll go to 0.5. That's not a very nice pencil. Let's change that. There we go. And negative 0.5. And it'll have the same shape, it'll just be half the size, so hopefully I can draw this somewhat neatly. That'll do. It has the general features. And now I want to move this whole graph down by 1, and I'll do this on blue, and our blue pen, because that's going to be the final answer. So instead of it starting at 0.5, it's going to move down by 1 and start at negative 0.5 instead. So you can imagine it starts at negative 0.5, and it's going to go down, and it's going to finish, because it's still got an amplitude of, it'll finish at negative 1.5. And it didn't quite reach the height it should have, so let's rub that out. And in the exam, you can take as many attempts as you want. And there's extra paper in the back as well if you need more. Okay, that's the general shape we want, so that's done. Just make sure it goes all the way to 360. There we go. It's not the neatest thing in the world, it's not hardly a masterpiece, but it has the general features as long as you mark on the important angles. So it ends at 360, so mark that on, and its halfway point is at 180, so I'll add that on as well. And there's no other features, really notable features in this graph because it's been shifted down so much. But I'll write this on the bottom as well to make it obvious where that occurs. Cool, and that's it. We've taken the cos graph, the black one. Actually, we'll label them all as well. So the black one was just the regular cos x, and the red one was the regular cos x, but it was compressed to a half. And then the final answer, the one we're looking for, is the compressed cos graph that's been then moved down by 1. That's us done. Let's move on to the next one. You'll notice sketch ones take a bit longer to explain and go through and talk about. It should be faster from here on out. Okay, so in the question it would usually tell you what the equation is of the form of, and I'll tell you right now. It's a cos graph, and it's of the form of cos of x plus some number, I'll call it d, and there's also some sort of shift at the end. So we've got a horizontal shift and a vertical shift. Let's figure out what they are. So it's a cos graph, and cos has its max at start, so the cos graph usually starts here. So that means it's been moved some distance across. Let's have a look at what it is. It's been moved from here to about here, and halfway between 30 and 60, that's 45. So that means it's been shifted right by 45 degrees. And we can show it the same thing's happened to the minimum. So the minimum's been moved from 180 to 235, so yep, we can confirm that it's been shifted to the right by 45 degrees. And usually we associate going to the right with the positive direction, but remember in terms of horizontal translations and stretches, it kind of goes against intuition, so this actually corresponds to a shift d of negative 45 degrees. Now we can see the graph's been shifted either up or down. Here it's obviously been shifted up because it's been moved from below the graph to above it. How much has it been shifted up by? Well, the usual cause graph goes from 1 to -1, something like that. Obviously, it goes right there along. But here, its maximum has been moved from 1 up to 2. So then C is simply positive 1. And that would be the answer here. These two guys here, let's just write it out below. So it's cos of x minus 45 on degrees plus 1. Okay, cool. Let's move on to the next one. Another equation given a sketch. This time it's of the form of a sine wave. So it's something times a sine wave. And this is the form that the question will give you in. Okay, so A is amplitude, so let's work at the amplitude. Remember, amplitude's either the distance from the middle to the top, but the more reliable method is just to look from the half distance from the bottom to the top. So distance from the bottom to the top here is from -2 to 2, so it's 4, which means that the amplitude, I'll do it here so there's more room. The amplitude is half that distance, so it's 4 over 2, which is 2. And because there's the graph that we flipped, A is just positive, so A is just 2. Now B is the number of waves in 0 through 60, the number of waves in 0 through 60, and you can see there's only one wave here, so it looks like B is just 1. However, if you look at the axis carefully, and occasionally this will come up, C60 is actually here, and is actually sketched out between 0 and 720. So this means there's only half a wave between 0 and 360. So here B is a half, or 0.5. And let's write this in full. So y equals 2 sine 0.5x. Nice. That's us finished the examples as set out in the concept video. Let's now move on to some past paper questions. And you'll notice in past paper questions that most of them are like these kind of questions where you try to identify the letters from the sketch. It doesn't often ask you to sketch it, but it occasionally does. We'll look at one of the examples as well. Okay, let's get started with this guy here. So we've got part of the graph shown here and asks us to find A and B. And remember, A here is amplitude, is how much the graph's being compressed or stretched by. And remember, the most reliable way of finding that is to go from the bottom to the top. So the bottom's here, in line with this, and the top's here. So this is the distance to 8, which means that the amplitude is, just 8 over 4, 8 over 2, sorry, so you half it, which is 4. And the graph that'll be flipped upside down, it's the right way up. So that means A is just positive 4. Cool. And B here is a phase shift. So let's have a look at this. Sine usually starts at the origin, but you can see it's been shifted right over here. But unfortunately, there's no angle given here, so you don't know how far it's been shifted. So let's look at another key part of the graphs to see if we can get more information. So you can see it crosses the axis here, and a sine wave usually crosses the axis halfway along at 180. So we can determine from this that it's been shifted to the right by 30 degrees, because 210 minus 180 is 30 degrees. So it's been shifted to the right by 30 degrees. And remember, a shift to the right is actually means that the B is negative. If you want to recap this, you can double check the horizontal translations concept video that I've made. So B at negative 30. There we go. So let's circle it. Want to make sure the examiner can see where the answers actually are. So A is 4 here, and B is negative 30. Let's keep going. Different type of question here. It gives you the values, and it's asking you to find a point on the curve. So here we can see that A is 3, and so that means there's been a vertical stretch, and the phase angle is plus 45, so it's been moved left by 45. So where does this usually occur? So let's quickly sketch out what a cos curve would look like. Cos curve looks something like that. And this guy here is usually a 180, and it occurs at the minimum amplitude. So if this was just regular cos x, then it'd be at -1. Okay, bearing that in mind, let's figure out the x value of this, the x coordinate. So it's usually at 180, but we can see from this the graph has been shifted left by 45. So if it was at 182 before and it's been shifted left, we take away 45, and that means it's 135, and these are all in degrees. So this here is at 135, and the y value, this guy here, would be -3 and 3 because that's the amplitudes. So this point A, it just has coordinates 135 and -3. So this is actually the only sketch question that I could find in the past papers. They don't come up very often, but apparently when they do, they give you lots of marks. This is 3 marks for a relatively easy question because this is much easier than the examples I've already shown. So let's get started. We can see the only change they've made to the sine function is there's a number for the x, or 2. And this just means there's 2 waves between 0 and 360. So let's draw our, let's try that again. Let's draw our axes out. And let's draw 2 sine waves. So we'll go up to the third line and down to the third line to make sure they're the same size. And this is why I drew the line before finishing the axes off, because I had a feeling I would overshoot. And then I'll write on our labels y and x. And you make sure to mark it the key factors, so it ends at 360 degrees. The midpoint when it finishes its first cycle is at 180 degrees. And we'll mark on the max and minimum, so the max here is at 1 and the minimum is at -1 because the amplitude is just 1 because it's unchanged. And we'll mark on some other key angles as well. Halfway between 180 and 360 is obviously 270 degrees, and halfway between 80 and 0 is 90. And we'll mark on the 0 as well, why not? And that's it, 3 marks just for that, and we'll even give it a little label. We'll tell the examiner exactly what we've done. We've plotted y equals sine 2x. Cool, let's move on. A nice little 1 marker. A key exam technique, look how many marks the question's worth, you know how much effort you should put in. So you look at this graph, we've got, it's asking us how many waves can we fit in between 0 and 360. So there's 1 wave, so B is 1. Oh wait, not quite, because it doesn't actually go up to 360. They've been a little bit sneaky here. And you need to imagine how, you realise that it doesn't actually go all the way to 360, it's only shown as part of the graph. So let's imagine what would happen to go all the way to 360. So there'd be another 120, which would take us up to 240. And then there'd be another 120 after that again, which would take us up to 360. And let's quickly write it down. And you can imagine there'd be another complete wave here, and then one more complete wave here. Obviously, they would read a little bit better looking than that, but you get the idea. So yeah, we can see there's 3 waves to 0, 360, so B here's 3. Cool, next question. Another 1 marker, that's what I like to see. Okay, so we've only got 1 change here. We've got a phase shift, a horizontal shift. We need to be a little bit careful here because there's a negative inside the actual bracket instead of positive, but we'll worry about that in a second. Let's figure out how far it shifted so far. And I've actually already drawn in here from I looked at the questions before that it's been shifted right by 45 because cos usually starts on the axis, and we can see it's been moved. It's now 45 degrees away from the axis, and it's now, that means it's been shifted right by 45. And remember, a shift to the right means that the phase shift is negative, so it's been shifted. We'd usually write -45, but since it's already a negative in here, A is just 45 because the graph is of the form here. And you can see if you plug in A equals 45 into here, we get this. So A is just 45. A, the amplitude, let's figure out that is first. So A is, remember, just half distance from the bottom to the top. So the bottom here is -4. The top here is 4, so the difference is 8. So that means the amplitude is half of this, which is 4. And since there's been no flip, A can't be negative, it must be positive, so A is +4. And remember, B is how many waves there are between 0 and 360. And we can see that there's 1, 2, 3 waves between 0 and 360. That's 1 wave there, that's 2 waves, that's 3 waves. So B is 3. And that brings us to the end of this examples video. I hope you found this useful.